How could you have for
Great, we are recording, so let's actually make a few solid notes about this pattern and linear sequences thing. Okay, I just want to give you a kind of idea that we can take forward, maybe make it nice and simple, but don't forget what we've done. We've done all our work on the patterns, yeah? So just to remind you what we were doing, we've kind of got these physical patterns that we turned into numbers and then we worked out rules. And I think on the whole, you were quite successful with these ones I gave you last time, yeah?
I have a question.
Yes.
You read T for N term. Can you just say N T?
Well, what I'm trying to give you is notation that you will see. So I think I remember when you get diploma level, for instance, they don't write TN anymore, they write UN equals 4N minus 3. So, yeah. All right. And then you'll see formulas, for instance, that look like UN equals N minus 1 type, things like that. So that's noted. You don't need to worry about that just now. We're kind of building that up. It's just that's why I do it, to get you used to seeing it. Yeah?
Is UN any different?
No. No, it's just a different letter. That's yeah. What I find is I used to teach something called GCSEs, which was a different course from my thing. They tended to use TN, right? T for term, nth term. But MYP, DP tend to use UN. I don't know. No idea. I even assume the T stands for term, to be honest. I don't know that for certain. Seems to make sense. I don't think it matters. I could be wrong, but it doesn't matter. But there's a couple of things I want to do today then. So just be able to write the general rule. I think we're kind of pretty close on that anyway. Use a rule to determine any value in the sequence is, I think, we're pretty much there. And just the one thing that I would like to make sure we can do, because I often overlook this, and it's considered one of the harder things. We did it at the end of last, I asked one table to do it, determine whether a value is in the sequence or not, but to also be able to give a valid reason for that decision. So we want to rattle through those relatively quickly. They're not new, but we'll make some notes. Maybe I'm going to give some of you what were not quite there a way to think about it. So let's, first of all, I've drawn a little table. I've done mine in preparation. Put some squares in the way so it looks like yours. Let's talk about some basic sequences. So, N stands for, do you remember? The position, yeah? Yep, we're writing this down. So N stands for the position. So N will always be 1, 2, 3, 4, 5, and so on, yeah? Why will N for a sequence like this, specifically, why will N not be like 3.4? What do you think, Ben?
The sequence that it is.
Okay, yeah, I think you got it, Brad.
It showed which one is. So in 3.4 wouldn't be all part of the sequence because it wouldn't be a whole number.
Good, I like that. It's got to be a whole number, hasn't it? Because we're basically saying, what's the first number in the sequence? What's the set? It doesn't make sense to, what's the 3.4th number in the sequence? Not saying that will never come in, but in this context of patterns and linear sequences like this, which have an application in real world, we are looking for a whole number. That's something to keep in mind, by the way. So why won't we have negative numbers in this context? Colton?
Unless you're going to have negative blocks or negative parts of a pattern.
Yeah, so it doesn't make sense, right? Again, we will see that in the future. It's not completely out of place, but what we're doing at the moment is thinking first term. So we have the first term. That's where we're starting. There are no numbers for us at the moment before this. If we take this into a different situation, then there could be, but for now. I'm going to give you a few, all right, simple ones, and maybe we can come up with a pattern like we were doing criterion B together. So my first pattern is
Wow.
wow, difficult one, right? So if I say to you, Tn equals, oh, suddenly it's a bit more. N, yeah, good. It's just n, right? Tn equals n. So this number, the number in the sequence, is the same as its position in the sequence. So if I said to you, what is the 50th term in the sequence?
50.
Hard one, that. 50.
Wow. Oh, this one I've ever seen.
Hardest. Well, we're looking at a few easy ones to explain something we talked about at the end. So this new one, Tn, I'm going to do 1, 2, 3, 4. This time I'm going to write 2, 4, 6. What do you think that is?
8.
8, 10. So what do you think Tn equals? 2n. Thanks for putting your hand up, Phoebe. Exactly what we like. 2n, yeah? So the 105th number in the sequence is 210. So that's the nth term, or the general rule. Okay? Yes. Same thing, another name, that's all. Well, we'll come back to that, but you're right. Comment. Good. So, another one. I wonder whether you can see where this is going. 1, 2, 3, 4. This time we're going to do 3, 6, 9, 12, 15. What's Tn? So, what is the 40th term in this sequence, James? Yeah, 120, good. So that's. Then when I make myself another table, yeah, one more. N, Tn, 1, 2, 3, 4, 5, 7, 14, 21. What's next? 28, 35. Tn equals, Riley? Yeah. 7n. So I've basically just written out a few. I don't think I've made another times table. No. I've basically written out a few of the times tables, haven't I? The times tables are a linear sequence. 1 times 7, 2 times 7, 14. Great. So we can also say that like the fourth number in the 7 times table is 28. Okay? So we could say the fourth term in the sequence of 7 times table is 28. Okay? Now, the reason why I've done this is because all our linear sequences are based around the times tables. All right? Because every sequence goes up by an amount, yeah? Just like the times tables. So when we have our sequences, what we do is I suggest, I hope you understand why, I suggest what we do is we look for which times table the pattern is based around. And how do we do that? Well, if you look at it, the 1 times table that you were laughing at, still a 1 times table, the common difference is
+1.
+1 every time. Because if you do the 1 times table, you are going up in 1. Okay? If you do the 2 times table, you are going up 2 every time. So the common difference is 2. The 3 times table, the common difference is 3. And the 7 times table, the common difference is 7. So basically, hopefully you're now making the connection between the common difference and the number that you multiply by n, because it's 1 lot of 7, 2 lots of 7, 3 lots of 7, and so on. Okay? Is that true for each one of them?
Tried it.
Yeah, we did it, didn't we? Plus 3, 3n. Plus 2, 2n. Plus 1, 1n. But we don't write 1. We just say n. Okay? Do you notice what it's not? It's not n plus 1 or n plus 2 or n plus 3. I will guarantee. I'm a little bit uncertain with you guys. Every time I say it's not n plus 1, everyone goes, yeah, no, it doesn't make any sense to do that. What's it? No problem. Then I give you an assessment, I get at least 2 people that still write it. At least 2. What do I? Yeah, I think I'm still go with it. I'm going to get a couple of you still doing it. Hopefully, you'll be the first group ever to never put that instead. Okay. Let's see. Okay, how are you feeling about it so far? Not much more talk about this on my part, but let's have a look at another sequence. All right, and I'll tell you how I create a sequence when I think of it and I ask you to tell me, and it might make sense to you. So it's always just 1, 2, 3, 4, 5, 6, whatever. Okay. But what I do when I try and write you a sequence and I'm saying, James, work out the general rule for this instead of chatting with Riley, you'll be like, oh yes, I can do that. But what I do is I create one in my head, but I choose the times table that I want it to be around first. So pick me a times table.
Times 9.
9. Okay. So I know that this sequence is going to go up in 9s. Okay? Which means the general rule is going to start with 9n. There's my starting point. I'm doing this in my head. So I know it's going to... What's the first number in the sequence if it's the 9 times table, I mean? 9. What I then do is I decide, how do I want to adjust my pattern? I don't want it to be the 9 times table. That's boring. Everyone can see the 9 times table. So I'm going to make this one harder for Kate, okay? By adding or subtracting something from that 9. Okay? So I'm going to go, I'm going to make it sort of easy-ish, and I'm going to start with the number 2. What did I do? Right. I took 7 away. So now I can think about it in one of 2 ways, up to me. I can either say, well, I know that I started with 9, but I did subtract 7. And now I can do the same thing. I can go, well, the next one would be 18, but I subtract 7 and I get 11. So that would be 18 subtract 7. 3 times 9, well, that would give me 27, but subtract 7 gives me 20. So I can do that every time if I like. Or I can go, well, once I've figured out the first one, I just go up in nines. So instead of working out using this is basically the general rule, I can now use the term to term rule and just say 29, 30, 38, and so on, yeah? And now I will say to you guys, I've tricked you now, I've made it hard. What's the general rule for that? And you're going to say to me, Mr. Potts, we noticed that you have based it around the 9 times table. I said, Mina, how do we know it's based around the 9 times table? What? Maybe, but that's not my first, but might be the way you would think about it. What's the easiest way I think that I know it's based around the 9 times table? Because the common difference is plus 9. Yeah? That's what you would see. You wouldn't necessarily see this 9 subtract 7, would you? Alright? So what would you then write? Well, you would write, Mr. Potts, it's not as hard as you're thinking, because if the common difference is plus 9, we know that the general rule is based around the 9 times table, so we would write 9n, because that gives you the 9 times table. I know it's based around the 9 times table. All I've got to do now is figure out what adjustment you did in your head, Mr. Potts. And we could probably do that easiest using which term? The first one. So I know that one lot of 9 should equal 9, but I get the answer 2. So what did Mr. Potts do? Minus 7. So I can do that with my 9n minus 7 is my rule. Okay? Right. I could do another one, but I'm not going to. I'm going to have you write one, just the numbers.
Like that on
However you want to do it. You notice I did it in my head. All you are going to do is you are going to create a little table. If you can try and do this in your head, that's amazing. If not, you might need to do something in the back of the book. So what you're going to do is you're going to create your own little sequence. Let's go up to 5 or 6. You're going to pass it to the person next to you, and they're going to tell you what rule you used, the general rule. Let's get this done in 5 minutes. I'm starting this just because Kate has a weird obsession with the number ending in 5. I want to show you this one. I just want to, because quite often people get scared when they start seeing decimals and things here, and I want to show you how there isn't really anything too scary, because the same things apply, which is we work out what the common difference is, and you can see if I did 4.5 subtract 3.5, I get the answer 1. Okay, let's just check. 5.5 minus 4.5, the next one is 1. So we can see, I mean, it's pretty obvious anyway, the common difference is 1. So Tn would equal just 1n. So we just write n. So although the decimals look difficult, actually the common difference and the start is not. But here we got this slight problem that Phoebe was highlighting, which is quite often people do just stop there and think, oh, I've done my thinking. But we do have to go back to the sequence and say, Tn is n. Well, if that was true in entirety, then Tn would be the same as n. And it's not. So we have n, which is 1. What do we do to get from 1 to 3.5? We have to add 2.5. Okay? Simple as that. Yes.
If it was ever like the term is 1 and the like yeah, well yeah, like it was 1 and then under it was like For TM, with TM.
Okay, ladies and gentlemen, you've all kind of ignored what Peter was saying. Let's just have a talk because it's nice when people ask these kind of questions, shows they're thinking about what could be going on. So could you give me an example?
So like for N, it would be like 1, 2, 3.
Yeah.
And then under it would be 2, 4, 6. Would it be like N plus N or N times?
Well, it could be anything to n, but the easiest way to write it is like we were doing earlier. It's just two n's, yeah? But 2 times n, that's what that means, is the same as n plus n. But the simpler way to write it is 2n, yeah? Colton?
What's the track? How would that one?
Okay, interesting one. Let's do a slightly different one that can confuse people. Let's do 10, 8, 6, 4. Okay. So this one kind of takes you a little bit above the level that we need to reach this year, but it's fine.
So
What's the common difference? What do we add on every time? -2. So we can either think of it as adding -2, or we can say we are subtracting 2. Okay. Okay, good. So same thing applies. The Tn will just be, it's -2 times n. I put brackets just to keep it clear, but we don't need to, right? No, what I would say though is, make it very clear that there's a negative sign. If it's not clear and obvious, and it's in an assessment, I won't assume there is. Okay, same thing then. How is it adjusted? This is where people can make mistakes because dealing with negative numbers is often tricky. So, anyone know?
So you would the -2.
Okay, so to figure out this term here, I would do 1 times -2, which would give me -2. That's why the first term's the easiest one to use. But I need
So plus 12.
10. So we must plus 12. Good. You obviously have good understanding. So we're going to add 12. That's the. A lot of people would say add 8 or subtract 8, something like that, because they're not quite so sure. But yeah, same things. Or by the way, for those of you that are really keen on how to communicate, quite often when we've got a positive and a negative, we would write it this way around: 12 minus 2n. Kind of makes sense, right? We start with 12, but we take 2n away. Yeah. Either of those is absolutely fine. Okay.
What's your number started in negative? Just to refill us.
Same thing. If your numbers start with negative numbers and goes up or goes down, still fine, James, Riley. Like I said, you've got the chair, responsibility. How do we feel about that so far? We all right? It's going to take a bit of practice maybe for some people. What's the final bit of the objectives that we haven't quite reached yet? Okay.
Determine whether value has a signal and given power.
So let's just finish off our lesson making those notes. I know we've done a lot of kind of writing today, but this is going to be good for your assessment. Yeah. Oh, did you see there's an assessment come out, criterion B and C?
I thought it was B the second.
It's not hard, but there are 2 parts to it.
Wait, I thought it was criterion B. It says B on there.
Did I not? I put C as well though, didn't I?
Yeah, but you,
No, I meant to.
on Friday there's criterion B. It says.
I meant to put C as well. Friday. Don't worry, you can't prepare.
It wasn't. No, it should be.
Communicating. It's just think of it like it's another class, but you have to sit quietly when you have to. Right, let's finish off with this question we're going to do then. So, I can say a sequence is given by the following rule. Tn equals 4n minus 1 is 58 a term in this sequence? Explain. Okay, so I'm sure some of you will have an idea, but I'm just going to go through a way now. We're running a little bit behind time. So how do I answer this question? Well, the way I would answer this question is like this. Okay, if 58 is a term in the sequence, we're saying that Tn has to equal 58, and we're asking what is n? Okay? I don't want the answer, I want to explain it.
I don't have that.
Okay, well, I'll come back to you in a minute. Okay, so if Tn is 58, what is n? So we're then saying 4n subtract 1 has to equal 58. Okay? And we are going to do what we call solve for n. And I gave you some work on function machines to help us with this. So basically, what do we do? Well, we would take n, we would multiply n by 4, we would then subtract 1, and the answer would be 58. Okay? So to work out what n must be, we're going to do the inverse, it's called. So we would start with 58 and we would add the 1 back on and figure out what it would have been. So 58 but 1 would have been 59. Okay? And then what we do is we try and divide that by 4. Okay. And we would say this would be a decimal. So 58 cannot be a term in this sequence.
Oh, wait a minute. So,
So before you say anything, I'm just reminding you, I'm giving you a way that you would respond clearly and coherently and well in an assessment if that question was asked. Okay? There might be a quicker, there might be a more efficient method to just get the answer. I'm giving you a way of communicating that answer clearly for someone. Go for it, Janice. Either of you, you were going to make statements.
I have a mistake about
If you times anything by an even number, it's gonna be even. So if you minus 1, it's gonna become all number.
Yes, that is also another very good way of answering the question. You can say 4 times n minus 1 will always be odd. Yeah? 58 is even, therefore it cannot be in the sequence. That is another good way of answering the question.
But in some cases, couldn't a decimal be?
Well, that's what I asked you at the very beginning. Can't be, can it? Not in this context. In different situations, where we probably have x's instead of n's, then yes, you can. But we're talking about, is 58 in this pattern that we're going? What does this pattern go up in, by the way, Amina? If we were to write it out, what does the pattern go up by? Max, what does the pattern go up by? 4. How do you know?
So
Because 4n. 4n means it goes up in 4s. It's based on the 4 times table. Kate, do you know what the first term in this sequence would be? No, there's no last. 58 is not even in the sequence. We've just decided.
oh yeah.
What's the first number in this sequence? Hey? It does go up by 4, but where does it start? No. 3. How do I know? It's some of you are going to get there quick. First term is just that number. 4 times 1 is 4, minus 1 is 3. Okay. By the way, just in case you do want to prepare in some way, just sit, chill, stop packing out. Bell gives me a couple of minutes, right? Good time, but I just want to tell you, you do want to prepare a little bit. We're going to do a bit more on this tomorrow, but on Friday, your test is you are going to be given a pattern of some kind, and you're going to be asked to write the general rule. So you can practice these skills on that a little bit, but I'm not going to give you the pattern beforehand. I'm not going to tell you about. You do know it's on linear patterns and general rules. And what we even do, I was looking at it, even though it's back there. You do know how to do general rules, linear sequences, whether a term is in, everything we've done today. We'll do a bit more practice tomorrow, but Friday we'll be doing that. You can compare if you can. James is going to come back and repaint my rules.